Hello and welcome back. Okay, in the last VGA video I did some final tweaks I wanted to do before turning the remaining breadboards in the VGA into PCBs, and then that gives me room to move on and start looking at the next steps in the VGA circuit. So I'm pretty happy with the progress we made, but let's have a quick update on where we're at and then we can talk about where we go from here. Right, so here's the build as it stands. We've got the CPU over here. You can't see the peripherals at the moment, but I've got the PCBs for the VGA and breadboards. Over here, everything is pretty much final, although I've got some tweaks I might want to make to the memory interface, but we'll talk about that in a future video. And here I've got both the palette and output circuitry. Now the palette's the central three breadboards here, and the output circuitry is mostly these three DACs, the additional wiring necessary to connect in the VGA cable. But I've got a couple of bits down here, which are the 574 used to make a 4-pixel delay to the sync signals, which is to make them line up on the outputs with the actual complexity of the rest of the VGA circuit. And I've got the little kind of kludgy hack I've added to clean up the signals slightly when I'm updating outside of the blanking intervals. Now I've only got the delay here on 2 out of the 3 signals it needs to be on, but they're the most important 2. But I've also got half of this D-type over here I can use for the same delay, but I didn't want to make the breadboards more complex. Because these DACs were already put onto PCBs, it's not going to be as big a space saving as with some of the other circuits, but we're going to eliminate this breadboard and most of this breadboard from the circuit if we convert the output. I can obviously base this very heavily on the DAC circuits I made. One element here of interest is the MOSFETs I added here for clamping the output during the blanking interval. I didn't have enough MOSFETs for all 3 boards, and we're not really seeing any negatives from that. So, I mean, we could spot it in an oscilloscope trace, but it didn't really seem to have any effect on the output, so maybe we don't need that. That might save us a little bit of space. Let's take a look at the schematic. I'm quite looking forward to this PCB because I'll finally have a VGA connector that I can plug the monitor into, and that's going to feel like a big step towards a final completion. So let's take a look at the schematic and see where we go from there. Okay, probably best to start looking at the VGA backplane. Now, interface syncgen tile map tile data we've got on our temporary backplane because we've got final PCBs for them. We have the palette and the output on breadboards, and the sprite hardware we've not touched at all. Now the estimated sizes I've got here are probably a little bit off. I originally thought the interface was going to be a bit smaller, but we left some space there. So I'm feeling it's a little bit tight up here. So really and truly, I need to fit the output and the palette circuit in as small a space as possible to give me a bit of flexibility for the sprite circuit, which isn't designed fully yet. Now, the palette circuit is very similar to the other modules in regard to having a block of memory that is accessed by the processor, but it's got 3 memory chips. So it's comparable to tile data, but with an extra 2 pairs of RAM chip and line driver. So I think we're definitely going to need a chunk of extra space for that. Now, this is the component that we are sure that the output will need, a VGA connector. We know it will need the RGB digital inputs. That's just over 6 squares high. So I'm thinking we make the VGA output circuit the full width and then as tall as it needs to be. Now we know that the bulk of the output circuit is these little DAC circuits. We need 3 of them, which we already did a test PCB for. So they're not going to take up much room. Then we need a few extra logic parts. Let's gather the circuit up, see how small we can make it, but my goal is to do this width and then as short as possible. Probably as far right as we can go. Let's assume we want a few pins on the side here because we're going to want some physical support to it. If we put these in vertically the way we did on the DAC test board, this ordering kind of makes sense. If I do these vertically, it'd be very easy to fit everything in horizontally. I would need to swap the ordering of all of these around though. This will be the wrong way. Or I can do these very similar to how I did it on the test boards. It was very tight when we did it before, but it did work. That makes an awful lot of sense though, but we would definitely need an extra square in height. Or would we? Probably get the wires around there. What does this gain us though? Let's build the rest of the circuit. Don't need to replicate that just yet. Now, we need the delay chains for the sync signals and the blanking interval. Now, by far the easiest way to do it would be to cross these in there like that. And people in the comments would be horrified by it. So Q0 to D1, Q1 to D2. So D0 to Q3 is separated by 4 clock cycles. Both these delay chains need an active low enable that's always on. I can't say I think that's ultra neat. I do need 2 of these as well. Right, let's take this whole connector over, even though we know we don't actually need all of these lines. So we don't need line clock or line reset here. So that's a 4-cycle delay on the blanking signal, horizontal and vertical sync. On the breadboards we didn't do the vertical sync, but I want to include it for completeness here. Now, horizontal sync, that goes to pin 13. Vertical sync is pin 14. Got to be careful here because a lot of the diagrams show things in a different order depending on whether or not you're looking at the connector from the front or the back. So 15 is not connected, 11 and 12 are not connected for us. All these middle pins are ground. So that should be red, green, blue, 5 is ground. It's a 15 pinned connector, 16 and 17 don't exist. I'm guessing that's these chassis ground connectors. That'll be easy enough to deal with. Okay, I think we need to finish up the circuit that we built in the last VGA video. That will give us a solid idea of the components we need. Definitely don't need the load line. We need an AND gate. You almost certainly want the fast version of that, even though we didn't use it for the breadboard version. Now, I used a 2-input AND gate device on the breadboard because that's what I had, but I did chain 2 AND gates up to create a 3-input AND gate. So it makes more sense to use actual 3-input AND gates. All right, I need the VGA clock. In the test circuit, we just used the memory region line for the tile map, but this isn't a single 3 input AND gate. We can get a bit more creative on that. Those are probably the 3 we're most interested in. So we definitely don't need that. There's our merged up memory access line, because these are active low inputs, so any of them goes low, and it together, our memory access line goes low. So then we did end up delaying the use of that by 1 cycle, be that one, and then we use the final output. We AND all of those together, and then the copy line is basically just the VGA clock, but it doesn't tick when we are doing a memory write to any one of these regions. So that brought power and ground in as well. Can't quite fit 2 of those horizontally. Vertically might work. Don't like it. Not got a lot of restriction on how close we can put these. These definitely want to be the other way around. I mean, 3 of those are going to work. Do have space down here we can use if we need to. I'd rather this board not be this tall if I could avoid it. Save myself an awful lot of soldering just by putting the sockets in here and plugging my pre-made DACs in. Don't think that's going to leave enough room for the pallet there. What's the alternative? This is probably more room than I need for the pallet. Let's assume I can route that. And we need 3 copies. I can reorder the way these are applied easily enough. Is that any better? Now, of course, this doesn't actually need to be quite on the edge like that. Yeah, that would be fine. Alright, so let's assume I can route that, fit 3 of those in. Maybe put that on the side. That would be a nightmare to route, but it is workable. Alright, need to fit these in a bit. So we could probably get away with that. Right, 10.5. For the pallets over here, I think we're better off putting the connectors over here. So I'm going to move that across, and then the VGA connectors are going to stick out here. Right, now I need to try and tidy this up. Now, firstly, I want these to be reversed. Now I'm going to save myself a little bit of effort here. I don't think these MOSFETs for the blanking were particularly needed. We've been running without them. So what we do need here is 2 in series to ground. So Then that needs to go to ground through one additional 470 ohm resistor. If I do this right, I can have a single one of these to do those 3 connections. So that's actually saved me 2 resistor arrays and the 3 MOSFETs. And considering how tight I am on space, I think dropping the MOSFETs is fine. We're working fine without them at the moment. I want something up here to stabilise the upper side of the board. If I can make that work, that's all the space in the world. Right, so the DAC circuit, if that's going to be our final one, we need to replicate it 3 times. Now I would actually prefer if the lowest points were in the 1 position. I really don't like the way this symbol was done. So 15 is a monitor ID, but we don't connect to it, as are 11 and 12 and pin 4. Right, so we've got an unused output, but we've got an entire unused gate here. The only sensible thing to do is take that to ground. So we've got 6 chips that need decoupling, and we'll get a bigger power line capacitor on as well. Wonder if I can reorganize these lines a little bit to make it more practical. Now that would keep them close to where they need to be. And that potentially provides quite a bit of extra support over here. Don't like the fact there's nothing up here for support. Move that down, stick a lone ground pin in. Right, this is pretty cramped. Right, part of me really wants to take 5mm or so off the interface board, shift everything down. That's such a lot of rework though. This feels extremely cramped. Right, let's have a think about this. I kind of feel like this would work, but it feels exceedingly cramped. So I'm having a bit of a rethink and I want to at least try an alternate. So that's what the width would need to be. Now that fits, doesn't it? I'm feeling quite good about this arrangement already. Bring that back down. This one's a bit more difficult though. Now with red, green and blue down the side there, what I'm thinking is the output circuit's here, and then the palette is here beside it, with a nice short jump for the red, green and blue outputs. We're going to end up with a gap. I think I probably will end up shortening this down slightly. I don't think we can afford the kind of empty space I've got down there. Okay, that feels achievable. Probably much easier than the old configuration. Right, so that's better supported. Going to be a lot easier to lay out. It does take slightly more space on the back plane, but I also think it's going to be a lot easier to separate out some of the signals. Try and keep the digital stuff away from the analog bits. So if we drop this down a tiny little bit, maybe 3 or so of these squares, that'll give us a bit more room on the sprite. And this space here, I'm thinking if we separate out the sprite merge logic, which we've started talking about separately, then that would make a nice standalone board. And that means we've got a nice flow of the data all the way up here with a conversion point here. So I kind of like that. I'm a lot more confident about fitting the palette into this space. Kind of envisaging one where the channel-specific components are right angles here, lining up with the outputs as they would be pulled in over here. And of course I've actually got room to write the name of the circuit and stuff on here. I'm far happier with this than I was with the other layout. Kind of feel like those are the wrong way around. Actually, those tracks are kind of long and annoying for something where we kind of need the resistors in different places. I think it'll be a lot neater if we just have standalone 470s. I'm going to make these 0603s as well. Probably a bit less cramped down there. Nice clear paste for the serial number. That's going to be a nice board. Right, time to route it. Right, I'm going to hide VCC and ground. These are just inputs to an AND gate. So we can just swap those to make our life easier in the routing. Doesn't seem like there's an awful lot of lines left. I think that's all my signal lines done. Now, let's do this as a 4-layer board. Inner ones are planes. Beautiful looking board. A quick tidy up of this while we're here. Don't need that copy anymore. Okay, what have I done there? All right, that's feeling pretty good. Every time I get a PCB made, I still get a little thrill from it, knowing that's something I've designed and had made. It's interesting, it's actually sideways compared to how I normally do this stuff. Okay, the alignment against the board is absolutely terrible there. I'm going to start again. I suspect what happened there was the direction I was pulling against it with the spreading tool. That's the decoupling caps done. Now these are 0603 components, and they're a lot smaller than what I usually use. But they don't feel particularly difficult. Now these 574D types are the most common logical device in my build. And this is the bit I've been dreading. Now, not only do I have to worry about getting these on correctly, people in the comments won't forgive me if I put any on the wrong way around. And it's almost guaranteed that now I've put the time into sorting these, I'm going to hit the table and send them all flying. Now these absolutely tiny passive parts, I always get a couple more out than I need, because if I don't, I lose one. That was a mistake. Guessing everybody noticed that watching the video. Now, I don't like holding these components the wrong way around like this, but obviously a lot easier to get the view on it from that side of the board. Just nudged a couple of the components there I will need to come back to. Now, when I first started doing SMD soldering at the start of this build, I didn't think I'd ever do anything quite as small as those 0603s. And just manipulating these items does give you a feel for how accurate and careful pick and place machines have to be. Now, I want to reflow this before I nudge anything else. Right, let's take a look. There's a couple of bits that didn't feel quite right on the reflow, but you can never tell at range. Not sure about that pad. Same there, actually. There's a few on these that don't seem perfect. It's also very easy for these pads to make a contact underneath that isn't visible on the outside, which I think is what's happened there. So I'm seeing some solder there and there. Not at all sure on that one. Now the thing with all of these resistor networks is for most of these pads, if they haven't made a good connection, I will still get an image on the screen, but it will be missing bits of one or more color channel. So rather than mess this board up by poking it with a soldering iron, I think I'm going to stick the pins on and see if we can test the board, because maybe we can actually see if it works. And the bulk of these connections are just one big strip. Beautiful. Not been looking forward to this bit either. Oh, it's really cool to see that in place though. Now these are as much about mechanical strength as they are about the electrical connection. So get a lot more solder in than normal. And this is the bit that was always going to be difficult. I think the outer pins shouldn't be any different than a lot of the pins I do already. So it's inner pins that are going to be tough to reach. Let's do the rest of the easy ones. I'm going to try switching to a different tip on the soldering iron. This one's a little bit smaller. Right, well, I think we've got a board we can test. Got to work out how to solve certain problems though. Now, making all these connections temporarily is going to be a little bit tricky. Now, more often than not, recently I've been making temporary interconnection backplanes, but I didn't want to do that here. The bulk of these connections are going to cross-connect from the pallet circuit. So what I'm going to do is see if I can get these into a board like this. Okay, so that will allow me to make the connections there. That's those ones, and these four in between are just going to be slightly more tricky. Right, what I'm going to try and do here is just make a temporary little interconnect. I've cut a small piece of strip board. Now, soldering this stuff is actually quite difficult. Now I'm used to modern PCBs with solder mask. Right, there is no cross connection on any of those. Good. I'm putting a second one in here because I think I need to double up on the connections somewhere. Which I know there's no cross connection, so I can actually put that across all of them. Right, that's good. Now I plug that in there, and I should have an easy way to connect everything. So I'm going to get the main build out and we'll give this a proper test. Okay, well that fits really well in that space. Okay, so mem regions, that has 5 lines here and only 4 up here, so I just need to compare what we are, but I can see actually the memory load line I've missed from this board because I don't need it. And there is a ground line at the end here. Let's turn it around to match that. If I skip the ground line, I can plug these three into there. And it's sync. And the bottom one of these is ground. Right, so then the signal connection. Now this is tight. So that's the clock going off to the rest of the board. That's a ground connection that's just tying to the rest of the board. That passes straight over to here. And we can pick that ground connection up and the clock connection there. Although assuming this works, we can route that stuff a little bit better. Now we've got all of these, which are the outputs. Need a longer one of those. Okay, so for the first time, we can just plug the VGA in like so. Now I'm going to power it on. That's kind of promising. It's very difficult to know if it's right or wrong. Now I'm not sure if anything down here is causing a problem. Okay, so all of this circuitry up here is redundant. Let's get rid of that. Right, now the only thing down here that's actually doing anything anymore is this proxy for the sprite merging circuit. Right, I guess we should probably just output something and see what we get. Now I am working on some demos I think are going to be very visually impressive, but I'm not ready to show any of those yet. Just go back to an older thing that does a bit more colour. Right, so that is definitely giving me the impression that, that things are not right. Let's see if we can diagnose this. Now the screen should be filled with black, which is palette entry 0 at the moment. So I'm going to try writing into the red channel. That feels like the palette write's not working. Okay, well the palette wasn't working, at least because I was writing to the wrong address. Okay, that should have been red. That should be green. That does not feel very correct at all. I suspect this circuit is working and then we've got some wiring issues on the DACs. See if we can work out what they are. Right, so this is red and I've pulled everything down. Here's 5 volts. That's not even remotely right. Let's go with a bus tester instead. Doesn't feel right. What on earth have I done? Blue channel seems to be giving us like the yellowy colour, but then so is maxing out the red channel. Or the green channel. Right, so this looks to me like The DACs are just completely not right, but total black and total white are coming out correct. At least the sync seems to be generating correctly. Now blue. That kind of feels all right. I must admit, I'm a little bit lost on things I can test easily. The bottommost line on the sync is ground. Then we've got horizontal sync and then vertical. Now the yellow trace we can just probe signals on. So if I look at the top bit of red, we just see that go up momentarily, start of the frame. So that's going to be just this logo. Now the lower bits are going to be very all over the place, but we expect to see the same in red, green and blue. Right, so at the moment we're getting what we expect out of the top of here. I could go and check all the bits, but I'm pretty sure we're going to see the same kind of thing. Okay, first mistake, this is blue, green, red. Which explains some of the anomalies, but not all. Oh, blue at least looks kind of okay. That looks like a kind of sickly green. It's not really right, is it? And the red output does the same. Right, so we're putting 0 into red, so we would expect to see zeros coming out, which is what we're getting. It's a bit more complex when we set the inputs high because they're going to be pulled low for all of the blanking intervals. But on the outputs from this, that's kind of what you'd expect to see. Let's flip all the way to the end and look at the output. That's red, green, and blue. Blue is correct, so then these ones are wrong. Okay, I kind of feel I need to pull this board back out, get it under the soldering iron, and we'll look at those resistor arrays. But the fact that one of them's right kind of implies I probably haven't messed the circuit up and it may just be the soldering. Okay, so we know there's a problem, we don't know what it is. I'm going to try and set up some kind of a test rig for it. Right, I need to make the connection here, and rather than pull the little adapter out, I'm going to make another one because I don't want to mess with the wiring we've already set up. Now, I've still got the superfine tip on this, but I suspect we're going to need it. Right, now we need to work out a way of testing this more effectively than I have been doing. So between red, green and blue we've got some ground pins. That's going to be kind of handy because then I can just pull all of those inputs low, like so. And the same here. Now, most of these connections we're not actually all that worried about. So these memory region lines I don't care about at all because we haven't seen any evidence that's not working, and if we have, we'd deal with that separately. So I'm just going to pull them all high. Sync, I mean the sync signals do come out, so I think that circuit works. So the only thing we're really worried about is the blanking line, which is this right-hand line, and we want that to be low. So I'm just going to pull all of them down to the ground with that resistor array. Now we're worried about these. Okay, for the wires I've got, it's best if we flip this around. As we're pulling high. Green and blue we're pulling low. Red's there. VCC, that one's ground. That's also ground. And then that's VGA clock. Now I can't pull that one way or the other because the outputs getting read in here get transferred to the outputs on the rising edge. So what I actually need is some kind of an oscillator circuit. And actually any old oscillator should do. This is one of the 1.8 megahertz ones we use for the peripherals board, predominantly because it's a multiplier for all the common baud rates for the serial port. There's no LEDs on this board at all, so actually I go in there. Alright, so we got this on channel 2 for the trigger. Let's confirm the clock. 1.8, that's what we want. Right, so I believe that is pin 1, which is the red channel. So that should give me red. And actually the one beneath it is officially the ground pin for red. Right, I'm seeing change there. That's bit 7, that's bit 8, or the 8th bit, so numbering from 0, that's 7 does nothing, 6 does something, 5, 4, 3, 2, 1. So I saw change for all of them apart from the most significant bit. But most significant bit is changing on the output of the D-type. So let's pull this thing and take a closer look. Right, so the main part of this signal comes out of that pin there to there, straight across, because we've got 2 resistors in serial, and then down to this one. Oh, hang on. Right, so there's a solder bridge between those 2 pins, but that's unrelated. Oh, those 2 pins are actually cross-connected on the circuit, so completely non-issue. That is the output for red. I mean, it doesn't look terrible to me. This does feel like I'm engaging in tilt shift photography. Alright, so that looks good. Is it possible that's not making connection? Actually, let's go the other way. So that's the red pin. I've got something there. It's very difficult to navigate at that level of zoom. Alright, that's good. Got a signal there. Okay, so I seem to have a signal that goes all the way. Now, when I first started scanning that, I felt like there was an issue there, but now it feels like there isn't. And now that line's working. Okay, I'm really worried about that. Specifically, my concern there is that that was definitely not working, so I reckon that one that looked most suspect, I may have just pushed the solder over and made it make contact. Let's not mess around with that. Now, that doesn't feel like the voltage change is double between those. Alright, let's have a look at green. That feels like it's working. Oh, hang on. So you get a very different signal out the blue. And that's the one that appeared to work correctly. And I've got no doubt that the difference in signal is symptomatic of whatever's wrong. Of course, the circuit to create the correct voltages is relying on the input resistance of the VGA circuit. And maybe we should simulate that. Right, there's a couple of pads here that look a bit sus. You've created a bridge there. Right, let's see if that has had any effect on the green line. Okay, so now the top bit doesn't seem to do anything. All the other bits do. Right, so this is a 75 ohm resistor, which is what these things are actually supposed to connect to. Right, so I am seeing with the bottom 7 bits high, which should be a value of 127, 0.6 volts. We're supposed to be seeing 0.7 when it's max. So what do we see on blue? Don't like that variability. We're supposed to see stuff max out at 0.7 volts. So I guess that could be about that. I'm not at all convinced blue is correct here. I'm going to go through and double check all of these solder connections. This solder bridge doesn't matter, but it's going to bug me every time I see it. It's another solder bridge, isn't it? And that one does matter. That was a definite problem, and hopefully I didn't cause that during this touch-up. Some of these pads look very different in person than in the microscope. There's all kinds of optical effects at play. That is a high quality demonstration of how to create a solder bridge. Okay, this is interesting. So if you see that pad up there, that looks very, very different than the surrounding ones. And that's more what I see in person at the right angle. So I think that's a pad where the solder hasn't flowed right. This angle looks next to no difference. A little bit here maybe. And I did that without creating a solder bridge. So that's the bottom right one on this. Kind of more what I'd expect. 4 and 5 look about the same, and then 6 looks a lot more. So maybe need to look closely at the lines that cross-connect bits there. Now we're back in red. Right, so the top bit seems to do less than it's supposed to. Alright, I'm looking at this and I've realised that I have made a mistake here. So out is supposed to be over here and that should be going there. When I swap these around, I've made a mistake with the pattern, I think. This should be going to there. And then that should be the output. Okay, I want to get this thing back in the build now. Now the problem we found does not explain everything we're seeing, but solder joints that are bad might explain the rest of it. Okay, so one of the early demos I created for the palette was a set of colour bars, and some nice graduated red, green, blue bars would actually be really handy to decode what's going on with the palette. So what we should be seeing here is red all the way down to here, green all the way down to here, and blue all the way down to here. Now this dividing line is consistent with what we now know. I've connected the output one step along the resistor ladder from where it should be. So that's kind of expectedly incorrect. Now, I've had a look at the circuit. I think I might be able to bodge that, but obviously for a final build, I'm going to need to update the PCB. But what I don't understand at the moment is why red and green are oddly cross-mixed. Right, so that's with all green forced to 0. That's definitely not right. And that's with red forced to 0. Suddenly occurred to me that I didn't check for cross connections on the analog side. And I think I've been a complete idiot. I'm not getting all my soldering equipment back out because I can see that when I was soldering these middle pins, which were really difficult, I have created a bridge here. And I imagine that was a really obvious, something I will have to cringe about whilst editing the video. Right, so I've got the green and blue I'd expect. Green looks a bit rough, but that explains why we were seeing some consistency. Right, this is excellent. So we're seeing red, green and blue. That's what it's supposed to be there. We know why we've got this fold in the middle. The only problem I'm seeing beyond what we know about is green has some banding in it. And that's kind of what I'd expect to see if some of the bits weren't connected properly. So we can divide that into 16 bands on the green, and I'm expecting the problem to be around about 4 bits from the top then. I suspect that we've got 1 bit that is incorrect. So our problem's going to be in here somewhere, either on this row. I think that's a solder bridge we created. I have to check the original video, but I suspect I might have created that one when I was cleaning up some of the other pads. That's looking good. Right, we've still got this fold that we shouldn't have. I'm now confident I found all the main issues with this board, which was some soldering errors, but also this horrible bit misalignment on the analog output lines. So I'm going to see if I can bodge around that, because for me that makes a really big difference. If I can get the 3 bodge wires in to make this board work for now, then I don't have to rush trying to fix the PCB. I can make that change and then just kind of grab that PCB on my next order. Whereas as it is, the build doesn't work very nicely, so I would want to rush that change. Let's pull this back out. I'm going to get the full soldering stuff back and we'll see if I can fix that. Right, let's take a look at this. Let's get a copy of the PCB for reference as well. So these are the red, green and blue lines. So these 3 lines here are the analog signals. To stand any chance of bodging, I'm going to need to cut those off and then connect separately to where they need to go. So this one I'll need to cut there and then connect it to there, which is actually the end of the resistor ladder. Right, so I'm creating a little bit of a sandwich there because then I'm not balancing on the pins. I think this red one at the top is going to be the toughest one because of the length I've got to work with. Actually should have tested this before. No, still got contact. This trace is incredibly fine, but got it. And now what I need to do is scrape off enough track further up for me to be able to solder a wire to it. This is removing the solder mask, and if possible I need to avoid removing any of the neighbouring solder mask off the ground fill, because then that would suddenly make this job really difficult. Now I could actually make these connections over the back where the pins are. That would be potentially much easier, but I'd end up with a far longer wire for it. Now this one is potentially easier to do on the back, but I'd have to find a different way of supporting the board. I should connect to these two, yeah. Didn't mean to do that. That's done. Still connected. Anyone got any advice on how to do this precisely? Right, that's connection unmade. I need somewhere to make the fresh connection. So there's where we broke the green wire, so I need to come above that. Now I think I've got a bit of the ground exposed there as well. Right, so what I'm going to try and do is get a little solder blob onto the bit where I need to make the connection. I think I've got some solder there, but it's tiny. It doesn't need to be very much at all. Actually, the other thing I want to do is check these against ground. Now, what wire shall I use for this? The connection I want here is either side of this point. First, I'm going to see if I can tin the ends. It's a rather delicate manoeuvre, this. This is not easy. That appears to be connected in the correct place. Now, I'm not expecting this bodge to have any degree of robustness. I just want it to work until I get a replacement PCB. That's kind of promising. Of course, now I see a resistance to ground because ground is at the far end of the resistor ladder here. Right, green has to go from there round to there, so I need a longer bit of wire than I cut. Kind of think that got a good connection there. I'm going to try and tack it at the other end as well. Two out of three done. Nice big solder bridge there. Really awkward positioning for my hands on the board here. I can't get the microscope in the other side. I think that solved it. This bit's going to be very fiddly. Sorry, didn't see that bit, I know. So that connection is there. And to ground, we're seeing that 3.34 type number that the resistor array creates. Right, that was a very fiddly job. Going to get the main build back out, plug it in, see if it works. Let's give this another go. Let's run our colour bar again. Right, this is interesting. So green and blue now look correct, but red I've broken somehow. Okay, let's pull that apart again. Okay, did have a lot of trouble with the soldering around here. I need to get everything else back out. I think I know what this is. Look on the green here. Get the bits, top 4 bits come out here into the first resistor array, into the second resistor array, and then they're into the resistors that run along the top. And that's where we've patched this in, because that's the correct output, which is the end of the resistor pair on the 7th line. Here, I had to do a slightly different arrangement of the resistors in order to fit the connector in. And I've stuck that in the wrong place. It needs to be between these two. So basically what we've got is only one of these resistors in between the most significant bit and the output, which means we'll be putting a much higher voltage out for that pin. And then this resistor is in the way of the entire rest of the array. So the other 7 outputs will have far less impact. I guess that's pretty consistent with what we saw. I don't like the way that's pivoting over there. Yeah, it's gone. I mean, that's a pretty good joint, so now we're back here again. It's in the right spot, but it's hovering a little bit high. No one's going to accuse this of being neat. The connection there and a high resistance to ground. Right, let's get this back in and test it. Right, so the colour bar's up again. Awesome. Oh, that's such a big relief. So we've got the red, green, blue, cyan, magenta, yellow. Now, even if this didn't work, I was going to probably call it a day, because I'm confident that the change that we've identified in the PCB fixes the problem we had. And all I had done there was just messed up the wiring on the bodge slightly, which is what I had done. Let's give this a quick go. There you go. So this has only changed a little bit from the last time I showed the parrots based on the tile data and tile map, but I've been working on the code that does this conversion. So I think it's slightly better, but the code changes I've been making to my underlying image conversion code are designed to support some more advanced features, which I'm hoping to show you in a demo in the not too distant future. I've got a working output board. I will need to do a new one of those, but that change is fairly simple to do on the PCB. I'm probably going to go and do it now, but I won't show that straight away. Okay, I'm really pleased I got that working in the end. Whenever I turn on a new PCB, I'm always holding my breath for a second just to see if it's going to work, because that means I'm either going to be filming my outro quite quickly and celebrating, or I'm going to be spending potentially the next few evenings, as I have on this occasion, trying to diagnose the problem and get to the bottom of it. And finishing a video with a working board, even if I had to put a few bodge wires in, is an awful lot nicer than having a failed board that I've kind of got to start looking into more in future. So that's a good thing. As it is, I'm going to fix up the design on the PCB, send off for a new one, but because we've got a working board, I can just move on with the project until that PCB arrives, and I've got a kind of gap while I'm waiting for other stuff. Now, the problems on that board, it's still slightly unclear We had the problem with the DAC design when I transferred the lines from going from low to high on the chip to high to low, or left to right to left, but that was a significant problem, but not the only one. I had the solder blob on the back when I was trying to solder the tricky lines I accidentally put onto some of the other lines on the VGA connector. That was causing a problem. I'm going to have to watch some of the video very closely when I'm editing and try and guess whether or not all the other work I did touching up some of the solder pads was actually of any value at all. That might have just been a wild goose chase, but it was probably okay to do it. As it was, we got it working. It was difficult to spot the exact problem because the multiple issues were kind of hiding one another. There was no simple explanation I could come up with for what I was seeing on screen, and the moment we solved one problem, tracking down the other was pretty easy. As always, a big thanks to all my patrons. I appreciate the support, and on this occasion a special call out to the people on the supporters channel on Discord who are giving me a little bit of a boost while I'm actually trying to solve some of these problems. So thanks again. Hope you enjoyed it. I will see you again soon. Goodbye.